All right, welcome back to the drive-thru, boys and girls. As always, sponsored by the deli. Hungry? Stop by the deli. Make yourself a pepper turkey sandwich on white with Kojak, Miracle Whip. Okay, this is 1.7 today, deductive structure. This is the foundation of geometry. Deductive structure is logical statements. Everything that we do will be based on a previous statement and or fact. We will build upon these statements, assembling a library of facts, and we will use those facts to make very good geometric deductions. Okay? So, we've got to know what a couple terms are. Definitions. We've already had a couple definitions here. Definition is the meaning of a term or a concept. That doesn't matter to you. But what does matter to you is that all definitions are reversible. I'll go more into what that means in just a second. Okay? Theorem. We've already learned this one time, but a theorem, again, is a mathematical statement that can be proven true. We will prove more theorems true than you guys will enjoy. Okay? A postulate is an assumption that cannot be proven true, but is assumed to be. Okay? The postulates are the foundation of the geometrical language. So, like the geometric language. So, for instance, one thing that cannot be proven is that through any 2 points there exists a line. You can't prove it, but it's something we assume to be true. We also assume that straight lines are 180 degrees. We can't prove it, but we assume it to be true, okay? So that's where we are in this class right now. It's important to understand that theorems and postulates are not always reversible, okay? And we'll go in and show some examples to that. So, you're going to hear a lot about conditional statements in here. Those are just if-then statements, okay? All deductive statements can be written in if-then form. The if-then form is used in court. If he had the victim's blood on his hands, then he must have committed the murder. That's an if-then form. Okay? It's also used in programming classes. If the number is repeating, then truncate the decimal. That is a Microsoft Excel command. Okay? Here are some if-then statements. I want you to read them. One of them is false. If it is thunderstorming, then the soccer game will be delayed. If I live in Cincinnati, then I live in Ohio. If it smells bad, then I must have forgotten to shower. The third one is false. It is written in the wrong order. What would be true is, if I forgot to shower, then it must smell bad. Say goodbye to the drive-thru, everyone. Boom. So, notice that the order of if-then statements matter. Take a look at the second one. Could I say that if I live in Ohio, then I live in Cincinnati? That would be a false statement. So the first thing you need to understand is that the order in which you write your conditional statements is certainly important. That's going to get into this idea of reversibility. What do I mean by reversible? Well, a definition is said to be reversible. Okay? Here is a definition. A right angle is an angle whose measure is 90 degrees. So, what if I wanted to write that in an if-then form? If an angle is right, then it measures 180 degrees. However, 90 degrees. What makes this a definition is that I could also write it if an angle is 90 degrees, then it is a right angle. Okay? So, that is what reversible means. A definition can be written as an if-then statement in either order. They will both be true. Now let's look at a theorem that we've already learned, the right angle congruence theorem. If two angles are right angles, then they are congruent to each other. You should know or remember that that is a true statement. It's a theorem we already proved. Now let's think about it written in the reverse order. If two angles are congruent to each other, then they are right angles. That is a false conditional statement. Look, I just drew two angles that are congruent to each other, and they are certainly not right angles. That's called a counterexample. That's how you prove things false. For the record, it is much easier to prove something false than it is to prove something true. All right, couple more slides. So, the converse of a conditional statement is the original statement written backwards. Remember, converse makes shoes. Shoes can run backwards. So the converse is the statement written backwards. So if they say, write the converse to if P, then Q, the converse would be written if Q, then P. That is your brief introduction into 1-6. If you watch this carefully, then you are ready to do your homework. Boom!